Welcome everybody and welcome to our session on automated public transport network design with PTV Visum. My name is Michael Bunschuh. I am software developer and technical product manager at PTV. Today I will show you our new line construction procedure that we included in the latest version of our product PTV Visum. Network design is the first step in the planning process for public transport networks. Input is the given infrastructure, like streets or railway lines, potential stops, and demand. Its result is the basic line concept, which consists of the lines making up the network, including the stops they serve on their routes and the headway they usually operate with. It lays the foundation to all further planning steps like timetabling, vehicle scheduling, driver scheduling, and finally, the actual operation of the PT network. Since it defines the framework for all these planning steps, the network design step has a huge impact on production costs, passenger perception, and operation of the PT network. And therefore, it should be carried out thoroughly based on human experience as well as on scientific insights. At this point, the automated public transport network design procedure comes in as an idea generator to provide solutions based on empirical data and optimization techniques, which also supports out-of-the-box thinking. It is not meant to replace the planner's experience, but to add additional ideas and concepts to the design phase. Of course, designing a completely new public transport network from scratch is not an everyday task, but nevertheless, there are several applications and use cases where at least a partial rearrangement of PT lines is necessary. This includes, for example, the case of a new piece of infrastructure, like an extension of a metro line, which implicates the rearrangement of feeder bus lines in the affected area, or the connection of a new residential area or commercial district to an existing network. Changes to an existing line concept may also become necessary to adapt to changed demand or ridership patterns that come up over the years. Another opportunity to provide completely new or adapted line concepts is when it comes to operating specialized services, like a night bus or weekends timetables. In other words, whenever there are different flows of demand compared to the usual home to work and back travelers dominating the ridership patterns. There are even applications in short-term planning, for example, when reacting to special demand due to events, vacation times, etc., or to restricted infrastructure availability, like closures due to construction sites. As you can see, there are many reasons why a PT network must be revised and replanned from time to time. I'm going to show you now how PTV Visum can help you with this task through our new line construction procedure.
The line construction procedure uses an explorative approach, a so-called genetic algorithm, which is a more or less trial and error-based search algorithm. The algorithm consists of 5 phases that you can see on the right-hand side. In the first step, we create a large set of potential lines, the so-called line pool. Then we assign demand to these lines, and then within a loop, we select subsets of lines and apply a headway for each of these, and then we evaluate this selection in a loop until we do not find any improved solutions anymore. One characteristic of this kind of algorithms is that we do not only find the best solution, but many good but different solutions. That's why we integrated the line construction procedure into scenario management. Let me show you how this looks like in Visum. As said, we are starting with the scenario management project. And if I switch to the scenarios here, you see there's only one scenario, which is the base scenario, which has no modification at all. And there are no modifications in the scenario. Let's have a look what this base version contains. Let me just load it and shrink the dialog. And then we see our famous Halle example. You can see there is a network consisting of links, nodes, turns, and the blue highlighted links here, this is the part of infrastructure which is open to tram, because we want to build lines for the trams. You can see there are some stops with the stop points highlighted in here. They are for on the tram lines, but also other ones, because there's already some PT in the network, which is lines for buses and for regional trains. We can just show you this surrounding PT. And I can mark some of these lines. So these are the existing bus lines. This is our surrounding PT, and only together with these lines, the trams will hopefully make some sense at the end. There's also regional trains, most of them serving the main station, which is over here. And there is demand, which I can show you by activating the desire line. So there's a matrix and a usual demand description for the demand segment public transport in the network. If we take a closer look to infrastructure, you can see there are some of these stop points which are depicted in a little bit different way. So these are the so-called terminal stop points. So I marked these as terminal stop points, which means that some of our newly constructed line routes for trams are allowed to begin or end over there, because it does not make sense to have them start or end anywhere in the network. You need some special infrastructure for this. So these are my selected terminal stop points. So we have infrastructure, we have demand, and we have surrounding public transport, but we do not yet have any information on vehicles or capacities, because this is part of the procedure parameters. So let's take a look at these. To do so, we reopen the scenario management dialog, mark the scenario that we want to work on, and here there's a new icon which says construct lines in the network of the selected scenario. We open this and we find the procedure parameter dialog for line construction. We have, first of all, the opportunity to select predefined parameters, as always in scenario management. And let's do so, for example, this predefined parameter set. What do we see here now? First of all, we can decide if we want to run the full procedure or only different phases, which is the construction of the line pool alone, or the calculation of headways and selection of subsets of the line pool, or everything together. And here we select the available headways that we want to take into account. Then there are some parameters defining which lines are fixed. So this is, we mark the surrounding public transport. So this is done by just providing an attribute of the line, which provides us with the given headway. And if that is more than 0, then this is counted as a fixed line. And there are some parameters concerning iterations. So the overall maximum number of iterations, which you should set to a rather high value. So this is just to ensure that in case there is no convergence, there will be some end anyway. But the main parameter is this one, the number of iterations without improvements, and the number of solutions per iteration. Then there is a page called Transport Systems. Here we first of all select the transport systems that we want to consider. So in that case, there are 5 different transport systems for public transport, but I only want to build lines for the transport system tram. And here we provide some information, some rough information about the vehicles. So this is a typical capacity that should be used in the calculation and the number of available vehicles for calculation. Then there is an attribute selection for the terminal stop points. This is what we just saw in the network. So this is also just an attribute selection for stop points, which describes at which stop points lines may start or end. And there are 2 detour factors, the minimum and maximum detour factor. They describe which line routes are considered to be useful for line construction. So the minimum factor, that is the factor that is applied on the long run. So the higher the factor, the more curved line routes are allowed to be. And the maximum factor is just applied for local deviations, and it's usually necessary to provide a higher factor for local detours to overcome some obstacles that sometimes exist to reach certain stop points and so on. On the next page, we find parameters concerning assignment. This is more or less just the selection of one or several demand segments and a demand period. Demand is interpreted the same way as for other assignments within Visum, which means we cut out the portion of demand from the associated demand time series and its matrices that falls into the specified demand period. Within the demand period, demand is considered to be equally distributed. One remark on the matrices to be used. If possible, you should not use the pure PT assignment matrix derived from a demand model or from observed ridership, because it already contains the reaction of travelers, no matter if they are modeled travelers or observed travelers, to the existing line concept. For example, if there is a relation with a good supply, meaning a fast, direct line operating with a reasonable headway, it will attract many travelers, so demand will be high on this relation. If you then use this matrix to measure what is a good line concept, you will consider a line concept providing a fast, direct service on this same relation as a good solution. This means using the pure PT matrix leads to a bias towards solutions that resemble the existing line concept. To overcome this effect, you might want to use a reasonable portion of the overall matrix before mode choice. If you have no demand model at hand, you could use a linear combination of the matrices used for public transport and car instead. On the next page, we find the objective function components. This is our way to measure the quality of a solution, so of a line concept. There are several different objectives. There are some that capture the view of travelers, so like the mean detour factor, the additional number of transfers, also the capacity violation. There are others capturing more the perspective of the operator. So this is, for example, the number of vehicles above budget, or the share of empty seat time, which is a scheme that is measuring the efficiency of a line concept. And there is unserved passenger kilometers. So these are travelers or demand that does not find any suitable connection in the given line set. And of course, this is an unwanted effect, and that's why there is some measure to capture this as well. There are some weight factors which are used to assign more or less weight to each of these objective functions within the overall objective. This is your way to express which criterion is the most important to you. Have in mind that some of these objectives cannot be met at the same time. For example, if we take capacity violation, which counts the overall time where you have more passengers than capacity on some of your lines, and the share of empty seat time, which counts how many empty seats you are carrying around. Of course, to get rid of capacity violation, you need to add more vehicles, so meaning decreasing headway on some line. But at the same time, you will get more empty seats on this same line. So there's often some competition in between of these objectives, and that's why you need to specify what is the most important and what are less relevant objectives in your planning process. On the last page, we define how results should be output, how many solutions you want to see. So this is first of all an attribute selection, where to put the calculated headway for the lines in the resulting line set. And then there's the number of good solutions you want to see. Remember that there can be more than one. And the so-called Pareto optimal solutions, and the number of these, we will have a look at these later on to explain what they can be used for. Now that we know what kind of parameters we have, let's just start the procedure and see what happens. And there's a progress dialog, and we can have it larger, and we can see the different phases. So the line construction itself, so the construction of the line pool is already finished. And now calculating the assignment step. And finally, we start with the iteration phase, where we can always see the currently best solution, its objectives, which are shown in this part here, and the lines and the headways. And of course, since all these bus lines and the regional train lines here, they are fixed, they never change, they are always existent and always have the same headway. So every selection is taking part in this area over here, where we see the tram lines, which are called LC for line construction, and some number, which is of course some artificial number, and the currently selected headway. And we have to wait until we reach convergence. Convergence means that we see 50 generations without any improvement. Finally, here we are. The system is now creating all the different scenarios and modifications, and this is what we get at the end. So let's take a look what we have now. You can see there are now some scenarios with some specific names. So there is one best solution. There are 6 near optimal solutions, and there are 7 Pareto optimal solutions. This is why we specified that we want to see 7 good solutions and 7 Pareto optimal. And there's the so-called maximum network. Each of these scenarios consists of exactly one modification, and we have the modifications over here. For each solution, there is one modification and one scenario based on this modification. What do we see within these solutions? Well, let's open one. We open the version without calculation results. Okay. And what do we have now? You see, in red, there are some additional lines. These are the lines that we have now, called LC something. And yeah, this is where they run. Looks not too bad. So these are the root causes for our new lines. Here are the respective headways. So we have 2 lines operating with a 10-minute headway, 2 others with a 15 minutes headway, and 2 additional ones running on a 30 minutes headway. So does this solution make any sense? Let's take a closer look what this solution looks like. First of all, well, the root causes, they seem quite usual. But for example, this line, why is there a line with a 10 minutes headway coming from the very south to the very west? So if we take a look at our desire lines, then we see, well, there's actually a high demand from the very south to the center of the city and from the very south to the west. And there is a direct connection between these ends. On the other hand, if we look at the top right and at this region over here, there are some stretches of track which is not served by any tramway line at all. Why is this? Again, as we take a look at desire lines, there is some demand, but not so many starting or ending in this region over here. And additionally, if we take a look at these stop points, we see that there are already some bus lines operating over here. So it seems to be a good idea not to add some tramway lines as long as we operate some buses already over here. This one is already operating with a 15 minutes headway, so probably this is more or less serving the demand that exists in this region. Let us take a look at the solutions from a higher level. To do so, we reopen the scenario management dialog. And remember that we do not only have one solution, but a bunch of solutions. And not only the solutions, but we also have all the objective values for each of the objectives for all of these solutions. To make them more readable, let me just make the header row a bit larger. Then we can see what we have here. So, for example, for the best solution, it reads like there are some capacity violations, 55. So this is overall minutes where we have some capacity violation. There are some additional transfers and some detour factor. Of course, this is always over 1. We do not need more lines than specified, nor more vehicles than specified. We carry quite a lot empty seats around, and there is some demand that we do not cover, but a rather small number. This is the weighted objective, and if we look up over here, the smaller the better, so this is really the best solution currently. We can take a look at others, and the different solutions, of course, they have different properties. For example, there is another solution which uses less additional transfers for our travelers, but on the other hand, it's using a little bit more than one vehicle more than we specified. So this is an alternative, or for example, there is another solution which needs a little bit more transfers, but also respects the given number of vehicles. Let us take a look into this near optimal solution number 2. We can open it. And if we do so, we see, well, this consists of exactly the same lines, but with different headways. And this is where these small differences in the objectives come from. Let's have a look at the Pareto optimal solutions as well. So these are not optimal solutions, but they are optimal in the following sense, that they are rather good in one of the objectives, and it's not possible to get a better value for one objective without worsening the situation for others. So there are more or less the extreme solutions to the problem. So let's have a look at an example. For example, this one here. This has a rather low additional number of transfers. But of course, on the other hand, you have to invest much more on vehicles and you have to provide more lines to provide the solutions where your travelers have to make less transfers when traveling within the network. We can also open this one and have a short look. And this here you can see consists of much more lines. There's also this region over here served by lines, and there are much more direct connections as expected. And at the end, there's also the maximum network. This is something else. So this is the line pool. If we open this one, then you see these are all the lines that have been constructed during the procedure. And this is quite a number. So you can use this solution to look up if the line pool looks as you expected, if there are some lines that you would expect in your network missing, then probably there are some parts of the infrastructure not available. For example, links blocked or turns are blocked, or the detour factors are not large enough. So it's not possible to create the line routes that you have in mind. What else can we do with it now? Let's open again our best solution, scenario number 2, and remember that there is a certain region which is not served by tramway lines at all. In this case, this is due to bus lines that are already operating here, but maybe it's not wanted. And that's why there are some additional objectives. In this case, it is the minimum and maximum services per hour. For example, here I just provide a user-defined attribute giving us a minimum service per hour and I want to see 4 services per hour at this stop point, a maximum of 60, so this is for operational reasons maybe. And you can take this also into account. To do so, I did not do so in my first run. I again select the base version and start the line construction procedure, but then I prepared a different set of parameters, and this one, the main difference is that now the objective minimum and maximum service level, that has now a weight. This weight has been 0 for the first run, and here is the attribute selection giving you just the attribute I just showed you for min services per hour at stop point. And we can run this now, again based on our base scenario. Let's do so. Okay, here we are. And again, we have a set of best solutions, some near optimal, some Pareto optimal, and a maximum network. Let's take a look into the best solution that we now have. And you see, well, here there are now some lines serving, for example, this dot point over here, where we have set some minimum or maximum. So this is this line here, which is operating a 15 minutes headway. So there are 4 services per hour at this stop point. Okay, so we see that our solution respected this newly defined restriction. You can also apply a more iterative approach by directly interacting with the procedure. To do so, well, first for clarity, let me just remove everything that we don't need for an example. So these are all the scenarios, but our best solution and all the modifications. And now I want to take something out of this best solution as from the output as an input. So I'm duplicating this modification and I need to modify it. And what I want to do is I want to declare this north to south line as an input to my next step, but I don't want it to run in a 30 minutes headway, but with a 10 minutes headway. This should become the backbone of my new network. And for clarity, let me just rename that to my tram line number 1 and finish editing of the modification. Then, well, define a new scenario, and this should now contain my modified modification number 2, the one where I turned the my tram line number 1 from an output into an input of the next step. And now, yeah, I can just again apply the same procedure with the same procedure parameters to that new scenario, which will keep my tram line number 1 because this is now considered as surrounding public transport, so untouchable, and will generate lines that form a useful network together with my tram line number 1. And of course, all the other surrounding public transport. Let's see. And now we can see that my tram line number 1 is contained in all the solutions that are listed here over time. Okay, finished. Now again, we have a best solution. Let's have a look into this best solution. And as expected, we still find our tram line 1. And there are now some additional lines that fit together with my tram line 1 to make up a useful tram network. Let me show you a final application. We now want to make the system react to changed demand and just recalculate headways only. To do so, I just removed for clarity everything we don't need in our project, and we need to define changed demand. So we make a new modification called changed demand based on the base version. And what this modification changes is, of course, we select another matrix in the demand description of our demand segment. Okay. And then we build a new solution, a new scenario for the best solution with changed demand. And we also mark our modification with the changed demand. Now, let's again open the parameter dialog and choose the same procedure parameter set, but now we restrict the procedure to only calculate headways. So this means no line routes constructed anymore, just recalculation of headways for everything which is not fixed. So the surrounding supply that of course remains untouched as well. Here we just have a certain selection. We do not save the parameters. I just want to use it for this time. This already always happens if I change something on the fly. Let it run. And you see that now there is a new bunch of solutions. So this is these. They all consist of modification 2 and 3. This is where we started from, and then one additional solution. And we see that already from the objective values that they are different, but they all contain the same selection of lines, but now with adapted headways that match the additional demand that we have in here. If you want to compare line concepts built by the line construction procedure to other scenarios like imported line concepts or manually built, then you don't have the objective values at hand to get a useful comparison. But of course, Visum itself provides ways to calculate similar values by its built-in procedures. So that's why we can use a procedure parameter set consisting of assignment and PT operating indicators. I can show you an example. Here we have an assignment step. It's a headway-based assignment, and you can directly use the result attribute, calculated headway from line construction procedure, as an input to headway-based assignment. In the put operating indicators procedure, there's also the notion of headway-based supply, and here also you can directly use the result attribute calculated headway to define what the headway of your lines is. So you can directly apply this short procedure sequence to our resulting scenarios. To do so, we just assign the procedure parameter set. I only want to calculate for these two, so switch off and run these two with the usual built-in functionality in Visum scenario management. So this will execute for these two scenarios, the procedure parameters, so the headway-based assignment and PT operating indicators calculation. As a result, we can define so-called scenario schemes on the scenario management level, and there are some schemes available that are rather similar to the ones from line construction, like the mean number of transfers, or this is unserved demand, or the mean journey time, overall service kilometers, and so on. And of course, these are then also available for your manually built scenarios. And as an extra, we can take a look at such a calculated scenario, and we get the usual and well-known volume bars in the network.
That's it from my side. I hope you enjoyed this session as much as I did and that you found some elements which you can include in your everyday work. If you have questions, let me know right here in the chat or drop us an email later on. Have a pleasant day and goodbye.